Welcome everyone to the iSchool Research Colloquium. Today we have a distinguished Schneider lecture. I welcome our in-person colleagues and as well as the online audience. My name is Jacek Wiska, I'm an associate professor here, and I'm running the colloquia this semester. So today we have Professor Mark Chignell from University of Toronto. See, what shall I say about? There's so many things to say about. Say nothing, Professor. Say nothing. No. So he has a PhD in psychology in 1981 from the University of Canterbury, New Zealand, and a master's in industrial systems engineering from Ohio State. Right? And then he started his academic career in the US. It was, I think, University of Southern California between 1984 and 1990. And then for the last 32 years, he's been a professor at the University of Toronto. Mechanical and industrial engineering, but initially it was just industrial engineering. And so his area is human factors and user interface design. He's interested in many related aspects, particularly recently in healthcare, cybersecurity, and aging. He's also has an entrepreneurial spirit, and in 2016,
I'm very good at losing money.
He started a company called Centivizer, which I think develops two kinds of tools. One is to promote physical exertion and targeted at older adults, and the other is cognitive games, also targeted specifically at older adults. He has had, as I remember, previous also companies as well. So one other thing that I want to say is that Professor Chignell tends to work with quite a few students. Currently, he has 9 PhD students.
I'm a five PhD and
Sometimes I know nothing.
and maybe 3 masters.
Okay.
And then
But it's usually around 10 or higher number from undergraduates, masters to PhD level. He has graduated many fine PhD students.
Yeah. Some of them turned out well. Yes, sir.
Some of them turned out well. For a full disclosure, Professor Chignell was my doctoral advisor.
I take no responsibility for this one.
We'll have a word later.
And yeah, so he's going to talk about interactive machine learning today. So without further ado.
Thank you very much, Jacek. I'm going to demask. This is the first time I've given this talk, so it's going to be a mixture of excitement and confusion and shuffling of mental notes, and we'll do our best. I'd like to talk to you today about interactive machine learning, which I think is a hot topic. And I'd like to talk to you about the relationship between human factors and HCI along the way, as I think it's relevant. So, quick overview of where we're going here. I'll talk about the history of human factors and HCI, motivated by a recent article I did on that topic. And I'll talk about the period of divorce where human factors and HCI diverged in the 1980s. And then I'll talk about the rapprochement I believe is happening as human factors issues surface again in human and AI interaction. And then I'll focus on the sort of meat of the talk, and I hope I keep my timing right. And I'll talk about interactive machine learning and the way in which we went from the 60s vision of augmented humans to today's vision of augmenting machines with human knowledge. And I'll finish off with a couple of case studies, one in physician experience design and one in anomaly detection in cybersecurity. And for this work, I'm heavily reliant on 2 PhD students, Lu Wang, who's now teaching at Texas State University, and I'll be visiting her tomorrow. And she did the work on the healthcare research. And then Miles Chung, who's finishing up his PhD, and he did the work on cybersecurity. Okay, how much time do I have here? Yes, there's a nice clock on the wall. I see that.
So the talk is until 2 p.m. So we usually have like 45 up to 1 hour talk and then 1 hour Q&A.
Okay, so I'll stretch it out a little bit. You guys are very generous with your time, and thank you. I really appreciate it. I've got two deans, or one dean and one dean emeritus here, so I feel like I should not waste your time.
So you should dumb it down for us.
I'm dumbing it down for me. Okay, so I'll start off with the history of human-computer interaction, and really I'm going to take this view of, we got to a certain place, but let's go back and think again about the concept of human augmentation. So I recently did a paper that was published online in September, and it talks about the evolution of HCI and human factors and integrating human and artificial intelligence. And I'm going to use this to motivate the first part of the talk before getting into the interactive machine learning material. So the research question I started off with in this paper was, why was HCI firmly part of human factors prior to 1983, and then almost completely divorced from human factors by 1990? And I know a lot of people, like myself, who went through that time period, who were kind of surprised at what happened. And I've talked to people about this, and they all have slightly different answers for why they think it happened, and I'm going to give you mine. And mine was based on several months of research as I put this paper together, so I feel fairly confident about it. So possible answers are that the concept of user was broader than the concept of operator, which required skills and training. And therefore, as personal computers came along and technology changed, it was natural to move to a user view and away from a simple operator view. A second answer is that user-centered iterative design was more effective than theory-based design. And I remember being in I won't say who the researcher was, but I remember being in a PhD committee in the 1990s, and the researcher had a very complex and very academically successful sort of theory of how you analyze human-machine situations and deconstruct the operator's task. And so the student was following this, and I asked the question, well, why don't you just use iterative design, right? Why do you need all this theory starting out? We can just simply start off in a reasonable place and just iterate towards the solution. And I never got a good answer to that question, and I really felt from that point on that user-centered design was kind of making these theory-based approaches obsolete. And then the third approach is that, well, cognitive engineering sounded really good, and there was a time, I think, in the maybe about 1988, where I was really a believer in this idea that if we understand human cognition, we can then design for it. But it seems to have been a dead end. And now if you do a search on cognitive engineering on Google Scholar or wherever, you're not going to see a lot of recent papers on that. And the final answer is that human factors engineers aren't good at coding. And what happened was the computer scientists ran away with it because they had the skills. And human factors engineers were busy talking about standards and guidelines and not being able to put things into practice. Now, there were some exceptions, don't get me wrong. But as a general rule, I think that applied across the discipline. Okay, so I'm going to start off with someone who wrote quite a bit about history of HCI. And this is my starting point, a gentleman called Jonathan Gruden. And ironically, I quoted him, and then I got these reviews back. And this paper was like, it was written by the other people. I mean, I joke that the paper was written by 7 people. My youngest self in the 1980s and 1990s, because I was using documents, papers from those times to supplement my memory. Me now, 3 other authors who are on the author list, and then Jonathan and 1 other anonymous reviewer, who I'm pretty sure I know of, but since he hasn't revealed himself to me officially, I won't mention his name. Let's just say he's even older than I am. Okay, so if you look at Jonathan Gruden's view of HCI, he had this idea of eras, which was very influential for me at the time when I was writing this. So he had this idea that, if you look at the users, they started off as engineers and then became programmers and finally got this notion of end users when we got sort of terminal-based human interaction with machines. And consequently, we had different disciplines. So, computing started off in electrical engineering, moved to computer science. And then this is where I started disagreeing with Jonathan, because he said, well, it turned into human factors and cognitive psych here in the 70s. But, I don't really think that cognitive science really got much play, and I'll try and explain why. And then he thought that interface as dialogue would be turning into cognitive psychology and cognitive science in the 1980s. And again, I think that hasn't happened. And then he talked about interface as work setting and social psychology. And this stuff, I think, branched off to computer-supported cooperative work and really got hived off the discipline. So again, I think I'm okay with everything, up to here and up to about here. And then I think it becomes a little bit more controversial. Okay, so Stu Card in the late 1970s, early 80s, and then with the book on psychology of human computer interaction with I think it was Tom Moran and Alan Newell, came up with this idea that you could use knowledge of cognitive psychology and cognitive science to understand a model of the person that could then be used in design. And this was the idea. And I did a edited book with Peter Hancock in 1988 on intelligent interfaces. And Stu Card had a chapter in there on the model human processor. And I remember being very impressed by this diagram. There was a fancier version of it in that this is what I could get hold of for copyright reasons. It was from the Human Factors proceedings a few years earlier. But he had the idea that there was precise timings for the perceptual processor, for the cognitive processor, for the motor processor, and then you had timings for the visual image store, the auditory image store, and so on. And it all looked good as long as you were dealing with time. But time is not everything. And it was as if we had like an EEG, electroencephalography view of the brain, where we knew exactly the time course, but we didn't know where everything was. So we didn't know whereabouts it was happening in the brain, and we didn't know what different tasks the operator could be performing. And it was very much a stimulus response view of the world, where the operator was always reacting to a stimulus and then responding. So as long as you have a stimulus response view of the world, and as long as you're dealing with RT, then this looks pretty interesting. But for everything else, it really doesn't have anything to say. So the model human processor became very influential, and there was a time when Stu Card was really pushing it and pushing psychological science as the basis for HCI. But in doing so, he kind of pushed it, human factors aside, but never really made a credible alternative with this cognitive science approach. Why? Okay, so this was my view of things in 1999. I did a book chapter with Peter Hancock and one of my students. And we were looking at, what was HCI, and you had this idea that HCI is just like this nexus, and that, you have tasks, people, devices, methods, and training and environment all pushing on HCI, each with their own points of view, and you had all these different disciplines that were involved in HCI. So HCI was, in a way, not a discipline at all. It was a combination of disciplines, or a result of a bunch of different disciplines, each trying to solve a problem. And the real issue is, when I looked back at all the writings about HCI curriculum and so on, what became very clear, it was all about design methods, and that there was no intellectual core in terms of like scientific content. It was really a process that was being uncovered in HCI, and very clearly, human factors didn't really fit into this beyond providing standards and requirements, because when you get right down to it, my knowledge of human factors people is they're not really big on design. They're not trained in design. They're trained in understanding constraints and requirements for design. And they're trained in understanding safety violations and so on. So, I think there was, the idea of a lost cause, right? In the Confederacy, this is the noble cause, and it wasn't about slavery, it was something else. Well, I think that a lot of human factors people have this lost cause idea that, somehow, HCI ran away from human factors and it's never been the same. But I would argue that you just have to go to HFES conference and a CHI conference to see the difference in drive and innovation and excitement, and to understand that really human factors just couldn't hang on to it. Okay, so we deal with a changing landscape, and automation and AI are just a new changing landscape. HCI can never stand still. It's a shape-shifting discipline. The H changes in terms of the knowledge and desires and expectations that people have, as well as their tasks. The C is changing in terms of technology adaptation and advancement. And as H and C change, I has to change as well. So, the first hit was the personal computer. So the personal computer comes along with IBM, with Apple in 1977, where it was when the Apple II came out, and then 1981 when the IBM PC came out, and then even more in 1984 when the Apple Macintosh came out. And each of these was a hit. And human factors had no response to this, right? So I remember in there was a book on VDT designed by I've forgotten the author now. I met him. He came to Ohio State and gave us a talk one time. But basically, they were arguing about things like the Europeans were saying that the color of a monochrome font should be amber, and the North Americans were saying no, it should be green. And this was the kind of the early HCI that was going around human factors. And once the personal computer came along, it just blew that away. And all these attempts, like the Smith and Mosier guidelines and so on, to sort of like create these rules about how HCI should occur, just became obsolete. And I remember having a terrible experience. I used to teach the web design guidelines from usability.gov. And, I would have, you should use frames in the situation, you should use tables in that situation, you should organize your headings and so on. They had all these nice guidelines, and each of the guidelines had a kind of scientific basis. So they would assess the quality of the research behind the guideline. So it was all very nicely packaged. And then one day I was talking about these design guidelines, and the student stands up in my class. I think he actually stood up, and he said, this is BS, basically. These guidelines are not used, they're not useful, we go out and do things. And it was true. By that stage, in the, I imagine it was the late 1990s, this might have happened. Perhaps, I guess it was still in Toronto at the time. What happened, what was going on was that the world was changing, and we were having consistency was becoming more important than constraints based on science. So if people were used to swiping right or swiping left or swiping up or down, that's what they wanted to do. And you could not go and build an interface that was based on some arcane human factors theory when people were already used to doing something different. So it was like the QWERTY keyboard beating the Dvorak keyboard, whatever, because that was what people were used to. So in the same way that everything changed with the personal computer, I believe that everything is changing now because of automation and AI. So let's look at automated vehicles as a case study. And this was from a paper that, again, I did with Peter Hancock and a bunch of other people. It came out in Human Factors Journal in 2020. And we were looking at the changing human role in automated vehicles. And what you have here is sort of a famous sort of levels of automation from ASME and other sources, even going back as far as Hancock and Kincaid with a Human Factors Journal article in 1984, basically talking about how humans and machines can cooperate in different ways with different degrees of control for each of the entities. So on the one hand, you've got the conventional driver where there's no automation and pretty much just an old-fashioned vehicle. And on the other hand, you've got computer automation where the drivers become a passenger. And then you've got everything in between, the enhanced driver, and you've got various areas of supervisory control in the middle here. And then you have the sort of progression towards a passenger. That's all I want to say for this figure. Now, if you look about, when should we be really concerned about the problem of human-machine interaction or human AI interaction, what you see is it's at the mid-level. It's somewhere between driver and passenger that we really have to start worrying and where the safety issues arise, because the driver starts to trust the automation, starts to get out of the loop, and suddenly has a difficult challenge when trying to re-establish control if there's an unsafe situation, or if the vehicle wants to hand off, or if the vehicle should hand off and doesn't know. So we have this strange area of intermediate automation where the automation is not quite smart enough, but the driver is starting to believe that the automation is smart enough. So this is the kind of the dangerous zone in automated vehicles. And it's the zone that we've just started approaching, I think, in the famous Tesla accidents a couple of years ago and so on. So as we get to levels of autonomy where automated driving is good, but not quite good enough, then we're starting to see these issues re-emerge about how we get the person to interact with the machine. And you could say the same for more software-based situations like cybersecurity, where there is no sort of vehicle, it's an engineered vehicle. We're dealing with pure software and data in doing the task. Okay, so one idea that came along in the 1960s and that kind of died off for a while was the idea of human augmentation. And I suppose Doug Engelbart coined the phrase, as I'll show in a minute. But then there were people like Steve Mann and others and Thad Starner who wanted to be cyborgs, and they put on a whole lot of equipment. And there's people who put chips under their skin and so on, augmenting themselves in various ways. But it's been a kind of a fringe element, and not many people are going to the grocery store and actually wearing a camera and speaking to other people at the same time and looking up data on the internet just with voice and a kind of augmented reality. So that really, is not mainstream. And Google Glasses, was another example of an attempt to sort of bring this idea to the forefront, which ran into problems, partly because of privacy concerns, partly because of, I think, fashion and appearance, and maybe just the product wasn't quite ready. So the vision was different in the 1960s. we're looking at situations today where things like automated driving, the human is augmenting the capability of the vehicle. So the vehicle is like doing its stuff, and then the human jumps in occasionally when the vehicle is brittle and doesn't have the knowledge or the ability to perform the task at that particular point in time. But in the 1960s, I remember, and probably others here may, or 19, if they can think about it in terms of the 1970s, if they don't go back as far as the 1960s, we had this idea that automation would reduce work requirements and give us too much leisure time. I remember reading newspaper articles when I was a kid, or hearing people talk about all the problem of how we deal with all that leisure, right? How we would kind of create fun things for people to do, meaning things for people to do, because all the work would be done by automation. And of course, it never happened. You know, we would take a thing like email and we'd just give people more work to do, or bureaucracy. You know, we'd have endless bureaucracy, and now we'd have, you know, more committees meeting and more rules being assigned and so on. And it seems like we are far better at creating work, new work, than we are at automating old work. So it's going in one direction. So it didn't happen, and we seem to be living in an age where the tools we have developed are concentrating power in the hands of fewer and fewer people, leaving many people disempowered rather than augmented. So we're living in a world where augmentation, if it exists, seems to be very selective. So let's check up on the original vision and try and pick up some of the pieces. So it's like, okay, I've painted this picture. It really is a little bit discouraging in some ways that we've been driven by technology. We've gone to places we never thought we would go. And now, you know, how can we establish at least some useful domain over the problem? So let's start off by going back to Doug Engelbart. This was one of his early pictures where he talked about augmenting human intellect back in 1962. It's clearly mimeographed. And if you look at this diagram, it's extremely rudimentary, right? You've got the human processes over there, whatever they are. You've got the artifact processes over there. And then you've got this man, of course, because in those days, everything was man. Like Licklider was also talking about man-machine symbiosis and so on. And there was this idea that somehow they would get together and they would each be talking to the outside world, and there'd be some kind of energy flow between them, you know. So this was deliciously vague. So when, you know, when someone like Doug Engelbart, you know, come to the CHI years ago to establish his kind of credentials for doing all these great things in the past, there was kind of a worship of his, you know, killer demo back in 1968 during the Fall Joint AI conference, where he was like or whatever that computing conference was, I forget the name of it now, but he was creating this link between Palo Alto and or Menlo Park, I think it was, and San Francisco, and showing that he could do, you know, video conferencing and everything. It was an amazing, amazing demo, right? But the actual concepts behind it that he was justifying it with the demo, I think were a lot more kind of dodgy and fairly simple. And then we look at another view, and you know, this is another sort of diagram about human augmentation. And here you see you've got the tacit knowledge spelled wrongly, but we externalize it. I don't think this was Doug Engelbart, maybe somebody else. Externalizing, structuring, and, you know, Google Images is a terrible beast, right? Externalization, structuring, and modeling over here. And then you've got this feedback, you've got the sea of information, and then you've got the structured information inside, and you've got this information sharing. So it was very much an information view of the world, and it led to the idea of hypertext, which of course was a great idea, but it wasn't everything. And I resisted the temptation to put Ted Nelson in this presentation because I knew I wouldn't have enough time. But just suffice to say that there's a lot of vague ideas about what augmentation is that in the current context look naive because they're missing so many of the elements that are important. So this perhaps is the greatest crime, right? The crime of the century, or maybe the crime of the millennium, which was when Tim Berners-Lee, in his wisdom, put in vanilla links into the World Wide Web. So you had no idea of provenance, you had no idea of authority. It was just like A links to B, and everybody instantaneously became a publisher, and you couldn't tell, you know, whether person A was a conspiracy theorist or whether they're actually presenting facts. And lo and behold, look where we are today. So later on, you know, people started saying, oh yes, let's have the World Wide Web. But unfortunately, the horse had long left the barn, right? If they're going to do this, they should have baked it in ground up, right? Back in 1993 or 1991, whatever it was, right? When they were doing all that stuff in CERN. So, you know, we don't have the unifying logic. We don't have the proof. We don't have the trust. What we have is some horrible beast that is consuming us all. And we'll see the results this evening or whenever the results come in. Okay. So So we'll carry on in this hopeful tone. So let's look at human factors and HCI approaches to human AI interaction. So I thought it would be interesting, just as a ground sort of establishing the baseline, to look at some recent publications where human factors researchers and HCI researchers have talked about the problem of humans interacting with AI. And I took for this papers in the CHI proceedings, recent papers, which can be regarded as, I guess, as authoritative of the state of the art from the point of view of CHI or HCI. And then I took a special issue in Ergonomic Design, which is a magazine, came out in 2020, but it was focused right on this topic, so it seemed opportune. And then we created this kind of table. And I don't want to go through this table in detail, except to sort of highlight the different approaches. And I'm not sure that one of the approaches is better or worse than the other. It's just what I'm trying to say here is you need both approaches. So for instance, from the point of view of the setting, human factors is looking at work settings, as it has always tended to do, such as algorithms for facilitating loan lending, which is a dirty business, I'm sure. And then over on the other side, you've got HCI discussing discretionary topics such as how to use AI to assist people in selecting strong passwords. Okay, and then if you look at the research on trust, you'll see human factors often uses theoretical approaches like C and V and so on. And whereas in HCI, you might be looking at the user point of view. So HCI is somewhat more democratic. Human factors is somewhat more theory-based, standards-driven. I think there's room for both, and you need both. And then, again, theory-based analysis of issues and perspective, whereas a preference for understanding users with various techniques. So it's the same things that have driven human factors and HCI all along show up symptomatically when you consider their approach to AI. Okay, so the last thing I'll talk about from this paper, pretty much, is this information processing view of human AI interaction. So I think there is a lot to be learned from both how HCI and human factors approach human AI interaction. And what I'll do now is I just set up a little diagram. So we have a set of task operations that an agent has to perform, whether human or AI. And then if we're doing human AI interaction, there has to be allocation of these operations. This is a standard feature that's been written about for many years. And then less commonly discussed is the idea of handoffs. And so each handoff from the human to the AI or vice versa requires appropriate interfaces and interactions. And this is something I think that we will work on collectively at the moment. And then there are various constraints and considerations in the associated design that has to be done, including the relative capabilities of humans and AI, the need for resilience to failures and errors, the issue of time and timing, when handoffs occur, how long they take, that kind of thing, and also the cognitive compatibility, how to make sure that we communicate in a way that people can understand and that the AI can understand. So this is kind of a simple diagram that we did a few years ago. The idea here is that we have these two stacks, there's processing stacks, and you could argue about which elements should be in, but the general idea is you're moving from perception over to execution. So this does look a little bit like the stimulus response stuff I was criticizing, but it's more task-oriented. And you can break it down, you can have nested tasks, right? So this could be combined with another one to make another task. So there's no reason why you have to keep it at a simple level. And the idea here is that different tasks are performed by the human and by the AI. For instance, in this case, dark blue shows task computation, and we see two handoffs. First of all, the sensing, perception, interpretation, task computation is handled by the AI. Then the assessment and decision-making is handled by the person, and then execution is done by the AI or the system. So we can imagine, every task can be perceived in this fashion. We're looking at opportunities for creating effective human-machine interaction.
A quick question.
Yeah, absolutely.
Is this kind of framework of handoffs and agents, is that based on prior work that was in like the study of human organizations or things like that, where you might kind of, each of these columns might be a job description or things like that?
Yeah, okay, so for those, I don't know, can anybody hear? Maybe not, but anyway, for anybody who didn't pick it up, the question, and I'll paraphrase it incorrectly probably, is, does this idea of handoffs and anything, and I think the answer, you probably know the answer already when you ask the question, but does it reflect, earlier work on management and how we assign tasks and hand off tasks to organizations? And I think the answer is, well, yes, I mean, something similar must be happening. When I put this chart together a few years ago, I didn't explicitly think about those. I did it de novo, but that doesn't mean I could well be recreating the wheel. And probably somebody must have written about this. And if I was serious about talking about this, I would go back and do the literature search and synthesize the work. But I haven't done it. But yes, it does look a lot like project management and workflow and allocating tasks. And in a way, I don't know if you're familiar with Marvin Minsky years ago had a book, which is kind of an informal book called Society of Mind. We was talking about all the different operations in the brain and the pieces that have to be done for an agent to be clever. So from a society of mind point of view, every task involving agents has to have these kinds of allocations of different tasks, and they all have different capabilities. Yeah.
And this also looks very similar to John Norman's human action cycle with execution, evaluation cycle.
Yeah, the gulfs of execution and gulfs of action. Well, I obviously I know Norman's work very well. So again, nothing's original, right? So I'm not trying to claim this original. I always have source amnesia, right? I never know where things come from, and most of the time my default assumptions it came from me, which is always wrong. But yeah, I suppose you can imagine a gulf of execution, a gulf of evaluation here, and a gulf of execution here, or something, or vice versa. But I think Don Norman never really went into details of the processing stack. He was just talking about the conceptual world of the user and the model, the designer's model, and then the actual model implemented in the system, and the interfaces that occurred every. So these were where Don's work would apply, or Don's work would apply, but still the stack is different. But there's nothing new under the sun, right? So I'm not claiming it's new. I'm just claiming it's me talking about it. Okay, so my hope is that human AI interaction will make HCI and human factors work together. And my observation is that in spite of the poor track record of human factors as staying relevant after the personal computer came along, that in fact the issues that human factors always cared about turn out to be incredibly important, and they're precisely the ones we need for human AI interaction, whether it's trust and reliance, situational awareness, workload, supervised control, safety, interoperability, and distraction. These are all core principles that have to be dealt with in human AI interaction. So either HCI can stumble along blindly doing its thing and making multiple mistakes that human factors engineers made years ago and dealt with in aviation, automation, and everything else, or else they can actually show some respect for the parent discipline, come back. I mean, it's like with a teenager, right? You leave home, you rebel, but then maybe a few years later you find the parents weren't so bad and you come back and visit them. That's how I feel like it's going to go with human factors and HCI. Okay, so now I'd like to talk about interactive machine learning, and I hope you forgive me for rambling on, but yes, it told me another bit of time and I'm taking it. So a simple view of machine learning is like this. I just did Google image search, and you have this machine learning model. You make some predictions, you feed the predictions to the human says whether he or she likes it or not, and then there's an improved prediction after incorporating the human feedback. Now again, this kind of diagram says almost nothing because you have to get down to nuts and bolts to really make this thing useful, and I'll try and show you some of the work we've been doing at the level of nuts and bolts. So another view of IML I'll just mention quickly is it's kind of off to the side, and this is kind of the Schneiderman view, Ben Schneiderman view, where you have human-centered AI. This is in the center. This is his baby in a way, and you have all these ethical considerations and stuff going on. And over here you might have a little bit of interactive machine learning. Over here you've got explainable AI, and then down here you might have something really cool like deep learning. Now, I'll be honest with you, I think deep learning's done some amazing stuff, AlphaGo and image labeling and stuff like that. But when you get a real data set like 4,000 labeled cases of delirium with mostly structured hospital data, it's really hard to use machine learning because you still have enough data. And so, all those, millions of neurons, you can throw at the problem, multiple layers deep, just there's not enough data to extract all the parameters. So generally you'll find a tree-based method is going to work better in those situations. And I found the same thing with cybersecurity. It's just not possible to get enough data to crank up the deep learning to the point where it's actually going to beat the other algorithms. So yes, but. Okay, so let's start off with a case study of interactive machine learning in healthcare. And this is work I did with Lou Wang. And we're going to have this sort of overall human-centered AI interaction. And we're going to assume that we have this kind of iterative process where we're producing a good model. And then we go through a stage of like the technology acceptance, where we have to get people to believe in the model and have intention to use it through customization and training. And then we're going to have some kind of implementation for industrial use and further feedback based on experience in the field. So it's not just an isolated instance of making good machine learning predictions. One thing I found in trying to do startups and get products out in the field is that users are surprising. And they'll do things in very unusual ways, and they'll find a way to break things, and they'll find a way to misinterpret things. And I've had cases where I've called people up and they say, okay, I plugged it in, I can see the lights flashing, but I just plugged it in again, the light's not flashing, and implying that the cable had something broke, right? Broken, just almost never happens. It's almost the most impossible thing to happen, but that's what they want to believe, and I can't tell them otherwise, right? So, dealing with real users in the field is very tough. So I have a huge amount of respect for this implementation science process down here. Anyway, the interactive machine learning in our view is kind of up here. We've added user-centered design to it. So we have to have a good experience for physicians and other clinical staff in order for them to make use of machine learning. So it really is a kind of UXD problem, but in the context of machine learning. So we refer to that as you'll see in a minute, as a physician experience design. So a slightly different point of view, but the same idea is we have this requirements acquisition process, and this is what a lot of people know how to do, interviews, focus groups, ethnographic observation, and so on. And through this, you have developers and designers, and you have your machine teachers, which are actually going to, and domain experts, which know about the domain, but don't necessarily know about the machine learning data science. And then between them, we come up with the requirements, definitions, and then from that, we do design and prototyping. We're in here. And in the design and prototyping phase, we've got various stakeholders, we've got the data leading to, they help us interpret the pre-processed data. Then we do data mining, we do feature learning. The experts will come in and identify the essential or influential features. We then do machine learning, we come up with a model implementation. And then we have, and these are all opportunities for interactive machine learning, right? So when we talk about interactive machine learning, it's not one thing, it's a collection of different things people are doing at different stages of the process. And then we're going to do the, evaluate our requirements. We're going to build an effective HCI interface. We're going to have machine teachers evaluate the ML models. And again, they need a kind of interface that allows them to do that evaluation effectively. And then maybe they rank the machine learning models, and then we decide, what we're going to use in clinical decision making. So there's a bunch of different things going on here, and there's going to be maybe some labeling processes over here that we'll talk about to determine, what are the targets that the machine learning process is shooting for. So it's a very complex situation, is what I'm trying to say. And there are no easy answers. So people can't just do the Engelbert diagram and say that's it, right? It's more than one diagram. Okay, so here's another way of looking at it. And in each of these red, what's that, a rhombus? Anyway, whatever it is, in each of those red things, we're going to get human interaction. So if we look at disease identification, evaluation, and we were using the problem of predicting delirium or brain failure, acute brain failure in elderly patients in hospital. If we look at, we start off with our developers and physicians, and they help us sort of select some, possible machine learning models, and they help us maybe choose features to look at, identify which data tables, and so on. we go ahead and do the processing, checking each time that we've handled data sparsity correctly, we've combined features appropriately, we've chosen the right diagnostic codes. There's just a huge amount. We get feedback from the physicians about the models, and then maybe we go away and revise things. We look at, like I said, the diagnostic codes we should be using. We select features, we do data mining and feature engineering. As I'll show in a minute, one of the things we've done is text mining. We've used sentiment analysis to create a very sharp feature for identifying delirium. We then do model parameter tuning, use holdout sets. In testing, we did holdout sets in the explicit future so that we could predict from past data to the future, which I think is more powerful than having a random holdout set. Then we give this questionnaire to physicians to find out what their requirements are for model performance, do more interaction. We then design and develop an HCI dashboard, which kind of takes all the learnings and the actual working model and makes it available to physicians. They then choose the results they believe and what to do about them. And then we're going to have a final model selection and maybe eventually an implementation of the process that they can use in their actual clinical decision making. So this is a very complex and onerous situation. We've been working for about 3 years now with physicians in a hospital, and just getting their time is kind of incredibly difficult. We found that they will not review stuff we write them and send them. We have to have meetings, and everything has to be in front of them in real time, because I guess they're just like tired, and it's just difficult to find time to read something. But humans are humans, and they always need to, right? Okay, so the idea of physician experience design here is we're going to develop interfaces that allow people to do the tasks they need to do when they're involved in interactive machine learning. So we're going to have experience that allows us to look at results and to evaluate things. We're going to have experience that allows us to review a dashboard of different alternatives, and I'll show you some examples. So here we have a calibration plot, and physicians really like this. I've got another example a little bit later. I think it's the same one, just bigger. Here, we might have questions that we ask them about, do they like calibration, what they want. Here we might have different drop-down menus where they can select different conditions. They can look at the data, look at the results, and decide what they want. Interestingly, physicians often prefer tables to figures, and I found this out 20 years ago when we were developing a point of care. Evidence point of care tool so that people could look at the available evidence before deciding on the particular case that they're facing at the moment. And we found that they would rather have a simple table than a chart. For whatever reason, they like to see the numbers. And then there's some other kind of screen you might do there. Okay, so this is the idea of physician experience design and how we combine user experience design with the problem of interactive machine learning, specifically with physicians. And as you know, the type of user has a huge impact on the type of design. So if you're designing an interface for engineers, it needs to look a lot different than if you're designing interfaces for librarians, as an example. Okay, so I want to talk a little bit about delirium sentiment analysis, which is a paper we've just written, and it's we're waiting for the doctors to give us their comments so we can send it out to the journal, which is very typical. And the idea here was we wanted to look at words that clinicians use to describe cases that are later labeled as delirium. And we used machine learning training to create a feature that measures delirium sentiment. And then we looked at how much delirium sentiment boosts machine learning prediction. This is not cheating because the actual prediction is done independently of the labeling. So you learn the labels on one set of data, and then you apply the sentiment feature to another set of data. Because obviously you don't want to include the knowledge of the labels into the prediction. So this is an example of 10 time segments. These are 6-month periods. And the blue line shows when we include a sentiment analysis, delirium-based sentiment analysis in the prediction. And the orange line shows, or the other orange shows when we don't. And what you see that, except when we deal with the sort of precision-based measures, we find a clear advantage. And in the F1 score, which is weighted, we find a clear advantage for the sentiment-based. So delirium sentiment was our most powerful feature. We had a boost when physicians selected features themselves. So we gave a bunch of features, and then the physicians said, these are the important features for delirium. We built a model based on that and focused on those features, and it did give a boost. But then when we added the delirium sentiment, that gave a bigger boost, right? So this kind of, you might say, well, that's not really interactive machine learning, but it's still human knowledge, right? So we're still bringing the human knowledge in. It's just already been written down. But I mean, we could have taken the nurses who are looking at or the radiologists who are looking at the brain scans, you know, and got them to write the things into the system in real time. So I don't think it's out of scope. And then this just shows the calibration. So the physicians were very concerned with calibration, model calibration. They didn't just want to know one answer, like they got delirium. Don't. They would like to know if the model says it's 50% likely the person has delirium, 50% of those cases actually have delirium. So that's what's called good calibration. And you saw here, there's an area in the mid-range where the model starts to underestimate the actual amounts of labeled cases. But generally, aside from that region between about maybe 30% and 50% or 45%, aside from that region, the model was well calibrated. So they were happy when they saw this calibration plot. So this is just an example of, for good physician experience design, you have to find out the things that matter, and you have to build a model that has the properties that they want to see. And they often care about things like recall rather than precision. So they figure you can always use a model for screening. So you can basically, you know, find out the likely instances and then double check them with some kind of gold standard method on top of them. But they don't want to miss cases. So this is generally true in many medical conditions.
So if I might, so this is a data presentation that helps them interpret the model evaluation.
That helps them trust. That helps them trust.
And thereby trust. But this is them looking at model evaluation statistics and asking for some alternative presentation of them.
Yes. So basically, we didn't give them a calibration plot. They said we have to have a calibration plot. This is really important to us.
So where does the idea of a calibration plot come from? The idea how they know of such a thing?
Yeah, well, okay, this is confession. We're not dealing with any physician, okay? We're dealing with physicians who have started the largest clinical database in Canada. It's got 30 hospitals, combined all the data from it. They've done quality control. They have millions of dollars of funding for this. It's mostly focused on internal medicine, but that's about something like 60% of the hospital. So it's a big swag of data. And they've been working on this thing for years. And one of the physicians, we work with three physicians in the main. One is kind of like a gerontology person, so she's a regular physician. But the other two are not regular guys, right? One of them did a degree in engineering science before becoming a doctor. So he's a technical guy. And the other guy is also pretty technically knowledgeable, although more so than the regular physicians. So we're dealing with a hothouse plant here, right? And I imagine that our physician experience, if I can say that, would be much worse if I was dealing with doctors from a community hospital or something, right? We're dealing with a high-powered hospital in downtown Toronto for people with a lot of training and experience in using data science. So that's now you've wrinkled that out of me if things incoherent and questionable. Okay, I stand exposed. Okay, so I want to talk about cybersecurity as the second case area, and this one to me is just as interesting as medicine, but in a different way. So we all know that large financial services companies are great risk. When you had the Visa or MasterCard break-in, a few years ago, when you had the Equifax, whatever it was, the credit scoring break-in, these things can cost potentially billions of dollars. So a bad day at a bank is much worse than a bad day somewhere else, right? So you just don't want to have cybersecurity break-ins. So we deal with one of Canada's largest financial services companies, and we've had a 3-year working relationship with them on this project. And you have your domain experts over here, you have your machine learning model over here, and there's a kind of expert AI partnership that we're shooting for that can give us more efficient and safer judgments of whether we're seeing anomalies which have to be investigated. So in any realistic situation where you have like millions of emails and other data transactions are happening a day, you can't afford to look at everything manually or even a small fraction of it. So you have to look for the high risk, try and identify the high risk anomalies, and then have those investigated. So they have what's called a red team and blue team, right? In any situation in cybersecurity, the blue team is defending against attacks, the red team is looking for weaknesses and trying to challenge the system. And they hope that between the red team and the blue team, they're going to have hardened defenses. But the problem with data exfiltration, which is the problem we addressed here, is that you can't rely on hardened perimeters because it's insiders. So if you have an insider go bad, or if you have an insider who's careless and an attacker compromises their account, or even if you have this insider who loosely gives away data, these are all points of risk, and they cannot be dealt with by just hardening the perimeter. So a compromised account may have the following anomalous behaviors: unusual login IPs, suddenly starting to send emails to too many other employees, unusual login times, subjects concerning topics unrelated to their business functions, and sharing files with external accounts frequently. Now, this unusual login time was a problem for us because the company has like employees in Hong Kong and Philippines and so on. So, there are login times from all around the world. So we had to sort of think very carefully about where people were when they're logging in and actually adjusted the time appropriately. Okay, so there are things that they know about that they can flag that gives us a basis for what we're doing. But the dilemma with handling exfiltration threats is that we've got both abnormal benign system users as well as malicious system users, so it's hard to distinguish between the two. And it takes too long for manual investigation, as I said, but it's hard for the machine to identify maliciousness and anomalous activities automatically because often it doesn't have the implicit knowledge. It doesn't really know about the work roles. It doesn't know about other things that a company expert would know about that indicate maliciousness, possibly. So an example would be medical data. You're storing the data either on the cloud or local server, and then you have either normal access or anomalous access as your decision. Now, this financial service company, it's got all the stuff on the cloud, right? So you can probably guess which cloud-based server it is, or which company. And they have a pretty good reputation. So now financial services companies, and probably the same is true in the US, are relying on the cloud. So they got over that hurdle of having it in-house and realized that probably the cloud is safer than servers in their own house, in their own organization. Okay, so we have a whole set of data which streams through in some kind of table usually, and then we have some kind of machine learning algorithm. It doesn't have to be a deep network or whatever, but deep learning, but something. And then we have domain experts using visualization tools to identify maliciousness. And then we have a model that distinguishes between normal and malicious users. Usually there isn't much support at this stage in the current state of the art. And once we get to the visualization and the anomaly detection here, people are faced with a whole lot of false alarms that they have to deal with somehow. So this notion of how to rank and screen false alarms is a huge problem for cybersecurity in many organizations. And it's been written about in the literature. Okay, so in looking at this problem, we did a review, which is currently going through a minor revision with HCI and computing surveys, looking at the problem of data exfiltration, and in particular looking at the issue of the human role. And what we found in looking at all the research is that there's been insufficient consideration of the human role. So again, it's like a lack of human factors. It's a lack of the obvious. And anybody who comes from a human factor background can see right away that there's something missing here. And we have all these people doing stuff, and yet there's no accommodation of how they can do things and how to make it easier for them to do things. So the idea with the active learning is you're going to present the human users with a prioritized list of instances to label so that you can train the model faster, right? So this is a good idea intuitively. And so you have a small set of labeled data to kick things off. You develop a model. The model then says what it's uncertain about, gives samples to the domain experts. The experts provide the label. The model learns some more, and eventually you have a fully labeled data set, which is presumably had enough human labeling to make sure the model is doing a good job. So that's the basic idea of adaptive or active learning. Now, there's lots of research questions you could ask about this kind of process. So, how well can our model prune our off-the-shelf model prune anomalies? And the answer generally is not that great. Then you can ask, how can we adjust active learning so that humans can work more smoothly with it? Maybe it involves some user interface design. Maybe it involves using different ranking criteria for prioritizing the instances. And then, how well does it actually work in practice? So we've been thinking about this for a couple of years, and we became unsatisfied with the standard approach, which was to sort of look for model uncertainty, find instances that are close to the decision boundary. This is an example of the binary classification task. And the problem we found was that often the model and the expert are both uncertain about the same cases, right? So if the model's uncertain about a case, but the expert is also uncertain about the case, don't bother throwing the case over to the expert because they'll have trouble with it too. And I know yes, I should be finished. I'm almost finished. Okay, so what we're looking at now is what we call a high information gain heuristic. So that if you look at the model certainty and you look at the human certainty, what you want to be is an area where the human is much more certain than the models. And we've been using confidence estimation by the experts, and we've done a study to show that when the experts have high confidence, the model is better in making predictions. So that they do seem to have some insight into their level of confidence, and it relates to their meaningful uncertainty. So now we're looking at this high information gain heuristic, and we're currently just doing an experiment, which is the final experiment of Miles's PhD, to demonstrate what happens when you use a high information gain approach. So in conclusion, I'm hoping this is about the right time. Yes, and I apologize for being a bit slow. Human AI interaction is one of the central problems of our time. Perhaps not the greatest problem, perhaps not the problem that's going to make the human species go extinct, or to lead to global domination by populist dictators, but still a problem. Human factors and HCI split up back in the 1980s, but perhaps it's time for them to get back together again for the sake of the children. For the moment, the focus is on augmenting AI, not on augmenting humans. That's where we are. We should just accept the fact and do it. And the focus on interactive machine learning, I would argue, is going to be very productive. First, because machine learning has a set of powerful tools and it's giving good results over many applications, so we know it is a good thing to use. We know that in areas like physician experience design are going to be crucial. Just like user experience design is pretty much useful everywhere, it's going to continue to be useful in the case of machine learning. So we should explicitly design for a good user experience for these technical people who are working with us. And enhanced AL with good anomaly labeling. This is just a case study. Is a promising approach for interactive machine learning in cybersecurity, as we're finding. And there are undoubtedly many other applications where interactive machine learning will be useful. So it's a great field. It's not crowded. Go ahead and join. You can take some of the research funds too. It won't affect me. So yeah, that's, welcome aboard. So that's the talk on interactive machine learning. Thanks so much.
So we have almost half an hour left, so we have time for a good number of questions.
Was it too short? Should have gone longer. I've got a few slides now.
Okay, questions from.
Yeah, hey, Andy.
Well, let me kick off with this. What's the role of education here? And particularly, I'm thinking about your telling of history, which paints quite formal divorcing of two subdisciplines, probably HCI.
Yeah, I mean, it's certainly separate conferences, right? So there's a certain amount of siloing.
But it's not even the conferences are a manifestation of education, right? Talk about human factors, essentially it's engineering.
Yes.
And
well, it used to be
protective
psychology. But you're probably right that it's gone more to engineering.
yeah, and that they're very protective of their identity in a way that, say, information and UX people are not.
Right.
And I think if I look at Kai, I don't see it as engineering dominated, and I think that's probably a more interesting telling. So I think part of the problem is the traditional disciplines struggled with the change in the world, and universities struggled with it as well. But I think human factors has intended to look inward rather than outward as a result, and protect its engineering status and its accredited status as a formal program. And then HCI was sort of soft. It's in the soft this way. And Stu Card is the interesting anomaly that he really wanted HCI to be very, very hard, and nobody else did.
Yes.
And it doesn't work very well. So you've got that sort of telling, and I think that matters when we look at this idea of them splitting up and coming back together again. And the real issue, you talked about, say, prototyping and evaluation as replacing science.
Right.
I don't think it does, because I think you can prototype a lot better, a lot faster if you have the science. You need the prototype, you need the data, because the theory is never enough. But your prototype is a theory. And if you come from a non-theoretical education, you could prototype what you like on the basis of some data you accumulated from a focus group or quick group, and end up with fairly crappy designs, as we see all over the world. The result of the products of design thinking are not reliable in that sense. So there's that issue, partly is education. And I think they've scaled it up to non-consumer products. Heaven help us, the airplanes, ships, and cars were designed by design thinkers. The consequences of error are enormous.
Right, which is why human factors owns those fields.
That's where the science still owns them.
Yeah.
So I think there's that tension, and it does come back, I think, to education and the way discipline identifies membership. And human factors has really locked into being in the middle. And I think that's a problem for it. But there's strengths in that, and we need to incorporate that into UX design. We need UX kind of programs to have a bit more science and a bit less quick prototype, get some users in, all good, move on. Because I think that might work for a mobile app that you just want to contact your friends with. A lousy way to design a vehicle.
Yeah, I was thinking as you're speaking, Andy, and I realized in my own practice, I actually do what you're saying. So while I've taught HCI courses for many years, I just handed it off to a younger professor this past year. In my practice, I tend to go with science-based stuff. Like when I was developing cognitive assessment games for older people, I went to the psychology MBAC task and the Go task, and I thought about what we know about the brain, and I didn't really sit there with a focus group of people saying what kind of cognitive assessment task do you want, right? So absolutely, and I've gone through the psychometrics and tried to establish construct validity with the other methods out there that are known to measure the things we're interested in measuring. So yeah, I mean, I kind of agree with you. Having said that, I think for discretionary tasks, I think you're right. For the tasks where there's an operator and there's safety issues and so on, human factors is the way to go and always has been. And for things like delirium assessment in hospitals, again, I think you can't just do pure prototyping design. I totally agree with you. I mean, ultimately, it's like most things, you do a bit of both, right? But both extremes are wrong. And in terms of engineering and human factors, all I can say is I've been in engineering programs as a PhD psychologist for 38 years, and you never stop feeling like you're a little bit under attack. And I won't say which discipline, subdiscipline of industrial engineering it is. They tend to be more math-oriented, and I had a case a few years ago, without naming names, where I had a PhD student working in data science, and there were some operations people on the committee of it. I said it now. And they basically, felt like I shouldn't be doing this work because I wasn't trained by so-and-so at Columbia, So I think there is this vast credibility issue, and yeah, I mean, so in some senses, nestling human factors within engineering and protecting, yourself is almost like a safety reflex. That this has.
What Kai did was push HCI into computer science, to try to anyway, where computer science was.
And of course, that was problematic until user interfaces became so important that they started making money out of it and they started realizing the potential. And at that point, I mean, like Ravan Balakrishnan, a HCI researcher, became the chair of computer science a few years ago. So now it's become totally mainstream. And not because necessarily the theory guys think that it's wonderful, but because it's been successful. I mean, success allows you to do strange things, right? Yeah, I think the rule is bring a lot of money and then you can do what you like.
Yeah,
at universities.
Sadly true. Yes.
Yeah, hi, what's your name?
Hi, I'm James Howison.
Oh, hi, James.
I often find myself in a situation when we have talks from like applied machine learning people, right? And they talk about a data set, they talk about feature extraction, all this sort of stuff. And then I'm usually left asking a question at the end that I.
Are you going to ask the same question again?
No, because I think your presentation has given me another option. So I usually end up asking a question I feel kind of guilty about, which is they say, well, it's better. And I say, is it good enough?
Yes.
Right. And they basically say, well, that's not my job. Right. At best, they say that's not my job. Right. I am, working with the snow globe here and the data set, and I've extracted all the information out of the data set. And so I don't know any physicians.
Yeah. I would just say the physicians have said it's good enough. They're using the model and they're actually trying to measure quality using the model in a hospital with delirium rates. So, so in our case, we can claim that.
So, and I think that's really exciting because now I have a model that I can point to and I can say, no, there are applied machine learning practitioners. That's not all that you're doing, but who are going into organizations, who are working, in these cycles to develop models that are going to potentially be acceptable to the users that are going to actually have real world uptake. But do you think is that a reasonable criteria for, the top line applied machine learning research? Like, what I see is we have like 98%, I got a data set and ran a bunch of stuff, and like 2% where they're actually engaged in a process that could result in a tool that would be useful.
Yeah. So okay. So I got some hope for you in a way, and it came from a paper that was turned down, rejected by a journal, which actually gave me hope, even though we were rejected. And it was the Journal of Biomedical Health Informatics, and we sent a paper into them on showing that our machine learning model improved, some percentage or whatever in delirium prediction. And they came back and said, we're not interested. There's too many papers like this, just predicting numbers and stuff. Tell us about your user experience pipeline. Tell us about how you involved your experts, because that's the most interesting thing here. So actually that made us, write the other paper. And, so I think there is now an appetite for going beyond the simple, our model's better than yours. Right. Because there's too much of that stuff out there. So I would say, yes, we need the pipelines, we need the user interaction, and we need the fielding in practice. And that should really be the criterion. The trouble is journals are not very good at this because they want to see, especially, NeurIPS or something, the hardcore journals and conferences, they want to see kind of like algorithms. They want to see like advances in algorithms. And that's what a lot of people are primed for, especially in computer science, which is leading a lot of this work. So it's a bit of a battle to show that, getting it used in the field is still a scientific, achievement. And generally, you have to show some kind of scientific value beyond simply saying people are using them. So that's the nature of the game, right?
Right. I mean, I think that is exciting. So that journal was essentially saying, yeah, that's all great. There's lots of that happening, but for really real world impact, we're going to need knowledge in these other stages of the broader process.
Yeah, I could have blown me away because I've seen so many of those. My algorithm's better in yours paper. And actually hear someone saying that, but probably that's the journal, right? That journal is not a typical, it's more of a practice journal. So perhaps they were more thoughtful, I think.
So next we have a question online from Deborah Tack, and if you could start.
Oh, Deborah Tack. How does she know about this? She must have seen on LinkedIn. Oh, hey, Deborah.
Hi, Mark. Yes, I saw it on
We
LinkedIn.
cannot hear you, Deborah.
Yeah, are you on mute?
It seems I'm not on mute. Can you hear me?
Is it our usability? So Deb is a talkout person. I don't know. Do you know Deb? She's a product person. I don't know. I did not get a stooge to come into this.
Yeah, right.
So Deb, you're about to say something wonderful about me, right?
I am.
I think the answer is no.
Where's the check? Yeah.
Can you hear me?
Type the question.
Anybody? Can you?
Do you want to type your question into the chat then? Because we can't hear you.
Why we cannot hear?
Oh, do you want to say something?
Can you hear me now?
Yeah, no, I don't think it's a volume issue. He's typing in the chat. Can you hear the chat?
You go like the audio setting and make sure it's
Yeah, just give us a second.
Those of us online hear you just fine, Deborah, so it's their fault.
Maybe try the same as this one.
Is your
No,
speaker
it's
turned
out.
down?
It says it's so loud.
Go ahead now.
Okay.
Hello, hello.
Hello.
Great.
Okay, so ask your question.
Do the people in the room hear me now?
They can, you're loud and clear. It's like you're sitting in the room, very scary.
Okay, great. Hi. So, hi, Mark. Yes, I saw this posted on LinkedIn, and I'm very interested in learning more about machine learning and AI. Mark actually introduced me to Torkai probably more than 20 years ago. And I've been working in industry in user experience research and design with a background in human factors psychology, probably about 15 plus years, in business intelligence, healthcare, education, and for the past 10 years or so, finance. And I'm looking to get back to healthcare, which is why I wanted to attend this talk. So my question, I guess, is it's sort of around the theory and the science and the showing value to stakeholders, and the tension that is out there in industry right now of like proving our ROI, having a sense of like there's a lot of sense that it's ticking a box now where you're just doing usability testing, or you're doing user research as part of a yes, we did that kind of pipeline. And I'm much more interested in understanding why things happen, not just instrumenting a website or a tool to see what is happening and when it's happening, but why. And so with the physicians that you're working with, and the pipeline that you're talking about in designing for the ability to interact with what the model is predicting and the ability to improve what the model is predicting, I see that there's a big need for it, because I see a lot of people doing machine learning and AI models to predict like all number of things, but it's a very limited set of people working on those things. So this is a very long-winded question, but how do you see industry and research and practitioners working toward really feeding back in an ethical and diverse way into the models to make better predictions, to let people interact, or to at least understand what the models are predicting? I guess that's really my question.
Deb, you really should have asked me that question 30 years ago. I'll start with the ethics issue, and we didn't address the ethics issue here. This is really Ben Schneider has taken. He's really used ethics as a centerpiece, his guidelines that he's developing for human-centered AI. But the other issues, one aspects of the project that I'm not involved with, but that the team is in Toronto, is bias and fairness. So looking at AI algorithms, i.e., for instance, under-predicting delirium in women versus men. So we did do an analysis of male and female and found no bias in the models. So that was a relief. So we have started looking at those kinds of questions. This is not directly answering your question, but I'll make a point in your preamble, which is that I think that UX people need to upgrade what they do to get more respect and to command, more authority in organizations. Otherwise, they become these kind of loose consultants, as you say, that are called upon to like put lipstick on the pig or paper over the cracks or whatever. And obviously, if they can develop skills in data science, product management, and interactive machine learning, then I think it gives them more strings in the bow. And I think that this is not high-powered computer science we're talking about. This is why I do it, right? This is more about how to make people work with technology. So it's just an extension of what HCI has always been. And the tools and packages that are available now, you don't have to be familiar with every mathematical aspect of the model to use it wisely, right? So So yeah, I feel like you send people, and we're talking now about quantitative models and UXD. Companies like Google are using that, and one of my former students, Tiffany Tong, is a quantitative UX person at Google. So I think that's an important way to upgrade and get more reputation, I guess, and more power. In terms of, I kind of lost your question because I went back to your preamble, but I know you were talking about ethics, one issue.
Yeah, and just how, I guess you're saying it's really just a classic human factors HCI kind of question of how do people interact with the source material that they're making complex decisions based upon. So how do we expose what needs to be exposed progressively as they're making decisions? How do, it's really, my question was really about how do we understand more about the why people need certain information at certain times, and how does industry and academia and all the practitioners, how do they work together to make that to move that forward?
Yeah, I mean, I think that the problem with UXD in industry is it's been a weak player. It doesn't have access to money. It's generally seen as a cost rather than a revenue stream, and it tends to get bullied by marketing, and that's just the reality. It's hard to change. I think in our case, I've chosen areas where there are natural advantages. So people want to publish results, right? And if we can show them good quality publications, it's highly motivating. And surprisingly, the VP that we're working with at our financial services company also really enjoys publishing. So every time we get a high quality publication, that's kind of a good deliverable for us, and it kind of pays for the research in some ways. That we get a chance to get the budget and get the access to the data and the access to the people. So we're doing experiments inside the company, with 10 of their workers at a time, hours of their time, which is normally very hard to get. But in this case, I think the management is right behind us, because not just because they're interested in the outcome, but also because they're interested in publishing part of the scientific process. So I think you have to play with whatever situation you're in. And in the case of the physicians, again, they're motivated to develop better standards of care. So for them, it really works. So I would say if you can attach yourself to results that people care about, and if you can create kind of useful deliverables for people, that's always what you want to do, right? And if you're in some kind of siloed organization where you're constrained from doing anything useful, then I think that's what you want to avoid. So I guess I'm just saying, pick your battles, right? And I think that UXD people need to go to fertile places and away from stony ground, to use a kind of biblical example. Yeah, hi, what's your name?
Hey,
Sorry, did you have?
but I think you can go ahead first. Yeah.
Are you sure?
Yes,
Please,
yes.
please.
No, I think because he also kind of answered the question that I had in mind. It was mainly about what is your role about.
Thank you.
Yeah, what do you think about academicians trying to maintain the software solutions or solutions that they develop? Because this whole area of interactive ML, it needs a lot of maintenance rather than doing novel work all the time.
Yeah, this is kind of a sad point for me, because I found it very hard to get money out of healthcare people. So when I work with doctors, I want their knowledge and I want their data, and I had to go in and get money myself. And what happened in this case was they asked me to be a PI on a grant proposal with them, which was great. But I was really busy during the semester, and probably it wasn't the best proposal. And we were ranked 47, and they funded up to 46. and after that, I think the physicians kind of lost a little bit of interest in working with me and finding money for me. So we still do the work, we still publish the papers, which is great. But money is always a problem, right?
Because essentially you're trying to develop a product, which is like handled better by industry than by academia.
Well, yeah, but you see, the flip side of it, the answer I was heading towards there, before I forgot, was that, they're building a huge amount of infrastructure. So they're hiring, maybe 10 data scientists. So they don't want to pay PhD students, but they'll pay someone else 4 times as much because they're part of the empire. And they're there, and they know they'll be there, and they'll keep being there. So they really are building this infrastructure. So the models are being maintained by them. So we develop the models and then they're maintained by the people. So they probably have a pretty good model, but from a research point of view, it feels painful because I have to run around, scrimping and scraping for money. And I know they've got a ton of money over there, but they're spending it on full-time people to solve the problems you're talking about. Yeah, sorry, what's your name?
And do you want to introduce yourself?
Oh, that's no Rava. I had lunch with him.
Oh, okay, beautiful. Elliot Hauser, assistant professor here. So thank you for this talk. This is really, really wonderful things. I want to contextualize that question of like, okay, was that from like a general purpose modeling of organizations? Because I kind of need that in my research. So I was hoping that you're like, oh yeah, here's the citation of how you might model hands-offs and things like that.
I'm not sure there's a single citation. I think it's a whole field of research.
Right. I haven't found what I needed yet. But anyways, I just have an observation and a few questions about the delirium sentiment piece. Like that was really, really wonderful. And I also thought about maintenance, right? The kind of longitudinal validity of something like that. But then also distilling down what actually is happening, right? The source is provider notes, right? So
in the case of text analysis.
In the case of the text analysis, the kind of delta, right, comes from the sentiment analysis, from notes that
a big chunk of the delta,
are kind of typing in there. And so they're a component of your instrument, right? If the practices of provider note take change over time, then that model might change over time.
Yeah, or if one of the hospital doesn't do such good note taking, then you can't really use that feature for their data. This is a big problem. When you have 30 hospitals with different practices, just getting them to all line up and do data reporting the same way is incredibly difficult. Even just lining up with they use different terminology. So we've had a lot of work done. Fortunately, you have this big team that they're developing with data scientists, and a lot of their work is involved with lining up the data between hospitals.
Well, hopefully, in addition to lining up the data, right, they have a little bit more of a qualitative perception of what's going on, because a case where the provider notes might get thinner is if the hospital gets a crush of patients, and so people are using more abbreviations that aren't picked up or things like that, right? So it'd be interesting to get a sense of the robustness of the model to potential changes, right? But then it also strikes me that what you've built is an AI-assisted form of organizational communication, interprofessional collaboration, right? Where we might have had a conference between all the different providers about a patient, but instead this is, at least one of the components of the recommendation comes from what another provider did, and so you might loop back around to some of the augmentation.
Yeah, I can see some of that happening with the hospitals are starting to compare notes about how they do quality assessment and how they manage things. So I think that is happening, and I think there's not my team, but the Gemini team who are managing this in the hospital. They are basically working with all the hospitals to standardize things, and we are seeing best practices emerge because of that kind of communication. So I think it's a very good insight, and it's probably what's happening here. So I'm not part of it.
Well, I wonder if there might be an opportunity to lean into that a little bit and ask us a different but adjacent question of how could this one day evolve into a more comprehensive way for providers to communicate with each other around, an AI-assisted way of kind of flagging, because when you look through someone's medical record, it's horrible, right?
Yeah.
But if the AI could say, well, this person should check for dementia because, and the explainability piece is then a potential conversation with another provider, things like that, right? It starts to become something that could really influence the way that healthcare is done in these organizations.
Yeah, absolutely. And this was part of our original vision for the model. So we started off predicting the past. And that doesn't sound as crazy, it's not as crazy as it sounds, because people didn't know the delirium status in the past. So essentially, we still had to predict the label, even though it had occurred earlier, right? And then the next goal was to be able to use that labeling process to do what's called silver labeling, where you use model labels to estimate rates of delirium for quality management, which is a huge issue, because we know that the delirium occurs far too frequently. And when hospitals try to intervene against it, it's very hard to know how well the intervention is going. So there's that. Again, I'm losing my point, which there was a
You get into the communication piece there.
yeah. So there's a communication piece where the teams are using the materials, meeting with each other. And they're talking now about having kind of EHRs where you have these predictions built into them, and cases where you can do prediction at admission. So based on the limited information on admission, you can predict the time course potential delirium and start to actually crank up some interventions, because there are some well-known interventions for reducing the possibility of delirium, which are quite effective, but they're also expensive in terms of labor and so on. So you can't do them for everyone. But if we can screen for those who are at risk of beginning delirium on admission, that would be a huge step forward. So they are discussing that. And if we had the AI tools, then I have no doubt that the hospital will start using them and start comparing methods. And if they could see that some best practices within one hospital are working and other hospitals have inferior practices, then that would be a real motivator for change. Because as you know, data, I mean, this is Obama's idea, right? That you create medical data and then you share it and use it to improve the system.
Right, thank you very much.
Thank you very much. Oh my goodness. Well, the bag is more important, right? You Texas bag is the most important thing. High school, look at that, high school.
Yeah.
Okay, so it's the official.
bag of goodies.
Built to last, as you can see.
Oh, yeah.
Thank you so much, just like the memories.
Thank you
Is
very much.
that connection?
And while we are wrapping up, we have 20 more seconds. Perhaps. We have also in-person presentation. This will be on a related topic. It's on human cognitive engagement with AI, or actually not enough engagement. And it will be Christoph Weiers from Harvard University. And this will be our last meeting before the Thanksgiving, but we will have a couple more after Thanksgiving.
Did you say Harvard?
Harvard.
I believe that's Toronto itself.
I know.
All right. Thank you very much.